Good morning, students. This lesson is of class 6 for the subject of physics, chapter number 4, Simple Machines, of your textbook, Concise Physics, Selena Publications. It is being submitted to you on 30th November 2020. Children, in the last lesson, we have learned about the simple machine and its various functions. To continue further in this interactive session, we are going to study about the different types of simple machines. There are 6 types of simple machines. Number 1, lever. Number 2, pulley. Number 3, wheel and axle. Number 4, wedge. Number 5, screw. And number 6, inclined plane. Now children, before discussing the different type of simple machines, let us understand an important term related to machines, that is mechanical advantage. The mechanical advantage of a machine is the ratio of the load to the effort. It is basically the advantage of using a machine. For a simple machine, mechanical advantage defines 3 major aspects. Number 1, how much the machines multiplies the effort exerted in moving the load, which means how much effort is being exerted on a machine and how much the machine is multiplying it in moving the load. So, the machine which help by applying a smaller effort to move a larger load are known as force multiplier. Another type of machine like wheel and axle, which is used in trolley, help you to move a larger distance. So in that case, mechanical advantage will define how much faster is the work done in moving the load by the machine. So this type of machine help to obtain a gain in speed. Now, the third major aspect is like pedals of a bicycle which help you to change in direction or point of application of effort. So, mechanical advantage also defines whether a machine allows you to change the direction or point of application of effort at a convenient point of direction. Hence, mechanical advantage is equal to load upon effort. It has no unit. The reason Both load and effort are similar terms. Both are forces and hence cancel each other. Now, children, if load is greater than effort, then mechanical advantage is also greater than 1. So, such a machine is called force multiplier. For example, a nut cracker. Here, less effort is required to overcome a greater load. Second case, when load is equal to effort, then mechanical advantage is also equal to 1. Here, effort is applied in a convenient direction. Example, pulley. Third case, when load is less than effort. Here, mechanical advantage is also less than 1. For example, a hockey player using a greater effort in moving a smaller load, but a larger distance. So, such a machine is speed multiplier. The first machine that we are going to discuss now is lever. A lever is a rod which can turn about a fixed point, and that point is called fulcrum. The principle of a lever is load multiplied by load arm is equal to effort multiplied by effort arm. Now, children, the figure shown says a rod AB which can turn about a point F. The rod AB behaves as a lever. The fulcrum of lever is F. If effort is applied on one point B on the lever and load is exerted on another point A, then the distance FB of effort from fulcrum is called effort arm and distance FA is load arm. So, mechanical advantage of lever is equal to load upon effort, or you can say effort arm upon load arm. Now again, children, if load arm is greater than effort arm, then you can say that mechanical advantage is less than 1. If load arm is equal to effort arm, then mechanical advantage is equal to 1. And if load arm is less than effort arm, then mechanical advantage is greater than 1. According to the principle of a lever, the turning effect of the effort at the fulcrum should be equal to the turning effect of the load at the fulcrum. That means load multiplied by load arm is equal to effort multiplied by effort arm. Now, depending upon the position of load, fulcrum, and effort, levers are divided into three classes. Now, children, let us discuss levers of class 1. As you can see, the levers in which the fulcrum is in between the load and the effort are called the levers of class 1. Generally, the effort arm of levers of class 1 is longer than the load arm. Therefore, mechanical advantage of class 1 levers is greater than 1. But it can also be equal to 1 or less than 1. For example, a crowbar. Here, the fulcrum is in between the load and the effort. Another example, a claw hammer, a pair of scissors, a beam balance, a pair of pliers, etc. Now, children, according to the formula of mechanical advantage of lever, effort arm is divided by load arm. Now see, in case of pliers, the shear are shorter. So, load arm is shorter than the effort arm. So, mechanical advantage is greater than 1. Now, in case of a beam balance, the effort arm is equal to the load arm. So, mechanical advantage is equal to 1. Whereas, in case of a pair of scissors, load arm is longer than effort arm. So, its mechanical advantage less than 1. Now, children, let us discuss levers of class 2. As you can see in the figure, the levers in which the load is in between the fulcrum and the effort are called levers of class 2. In class 2 levers, the effort arm is always longer than the load arm. Hence, the mechanical advantage of class 2 levers is always more than 1. For example, a nutcracker. See, children, the load is in between the fulcrum and the effort, and the effort arm is longer than the load arm. Similarly, in case of wheelbarrow, the load is in between the fulcrum and the effort. And you can see that effort arm in this case is also longer than the load arm. Hence, mechanical advantage more than one. Now, levers of class 3. As you can see in the figure, the levers in which the effort is in between the fulcrum and the load are called levers of class 3. Here, the fulcrum is at one end and the effort is close to the fulcrum. Thus, the effort arm is always shorter than the load arm. So, in this case, mechanical advantage is less than 1. The few examples of third class lever are fishing rod. Here, the fulcrum is at one end and the effort is close to the fulcrum, whereas the load is to the other side. So, effort arm is shorter than the load arm. Another example, forearm of a person holding a load. You can see that elbow, it acts as a fulcrum and the effort is in between the fulcrum and the load. Another example, spade. Effort is in between the fulcrum and the load for third class lever can be seen in that. Sugar tongs and knife are also the examples of third class lever. Children, you have well understood the three classes of lever which are differentiated on the basis of the position of fulcrum, load, and effort. In first class, fulcrum is in between the load and effort. In second class lever, load is in between the fulcrum and the effort. Whereas in third class lever, the effort is in between the load and the fulcrum. So you can pause the lesson and try to answer the following questions on the basis of what we have learned now. Question number 1. In case of a lever of third order, the effort arm is always dash than load arm. Number 2. In lever of first order, dash is in the middle of load and effort. Number 3, Nutcracker is an example of lever of dash order. Number 4, a pair of scissors is an example of dash order of lever. Number 5, a lever in which effort arm is always longer than load arm is lever of dash order. Number 6, the force applied to a machine to do mechanical work is called dash. Answers to above questions are: number 1, shorter; number 2, fulcrum; number 3, second; number 4, first; number 5, second; and number 6, effort. Thank you, children.